An unbiased die is thrown twice. Find the probability of obtaining a 5 on the first throw and an even number on the second throw. So, the first throw of the die will not influence the probability of the second throw of the die. The two events are said to be independent, i.e. the first throw and the second throw are independent of each other. There is no effect. What you get on the first die does not affect what you get on the second die. So, from conditional probability, we have the probability that B happens given that A has already happened is equal to the probability of the intersection of B and A, or B and A happening, divided by the probability of A. If we rearrange that, we can write the probability of A and B, it doesn't matter which way round we write these two, is equal to the probability of A times the probability of B happening, given that A has already happened. Now, but B is not influenced by A, and therefore we can say that the probability of B given A has already happened is equal to the probability of B. And therefore, for independent events, we can say the probability of A and B happening is equal to the probability of A times the probability of B. This is known as the multiplication law for independent events. So let A be the event obtaining a 5 and B be the event the number is an even number is obtained. Therefore the probability of A is going to be 1/6, because there's one way of getting a 5, and the probability of getting an even number is 3 out of 6, which is equal to 1/2. Therefore, the probability of A and B happening is going to be the probability of A times the probability of B, because the events are independent. And therefore, we can say the probability of A and B is 1/6 times 1/2 probability of A times the probability of B, which is equal to 1/12. So this has been a video to show you how in the introduction of what is known as independent events. I hope you've understood, and I thank you very much for watching.